Now we are directly going to see the embedded based project, so which is based on the ESP32, and we are going to blink the LED. This is the very basic program. So inside VS Studio Code, you can find extensions here. So inside that, you can directly install ESP IDF. So if you install it, then after installation, it will open this kind of window, and in this window you can configure project. So we are going to open the new project. So inside that it will ask the some basic parameters. So now we are going to create a blink, then the storage where it has to store, and then we're going to we have to select what chipset we have buy. So there is lot of versions are there, like different versions of board. What we have is that ESP32 kit, rover kit 3.3 volt. So that's what we have. So we can select. Then you have to connect your ESP32 board to your port, any port. So it will automatically connect to that port using normal ESP2 BTEC cable. Then you can choose that. Then it will ask the direct. But what we are going to do is that we are directly going to use the template which is already there. So we are choosing that. So here extension or ESP IDF it will ask. So you are going to do the ESP IDF. So inside there you can first have the three projects get started. So you have a number of projects inside there. So you can work on that. So the first program is that we are going to do that blink. So then after that you have to do the create project using template blink. So you click it, so it will open the project. So open a new window to such scale. So we are opening that in new window. Then in left side you can see the folder of that. So inside main, the main program will be there. So if you double click it, the main program will open. So as you can see, this is the free uh, uh, program for the basic LED blink. But inside this program, they have declared a lot of header files and a lot of inbuilt code to access that LED very easily. So that's why we have declared this kind of function. So as you can see, normally every program have a SDDIO. Then we have declared free RTOS, task kind of things. Then we have declared GPIO dot h. So driver, inside driver folder we have a GPIO dot h, which means general purpose input output header file. Then we have declared basic ESP slash log. So we have to print a normal printf also we can use, or normal log file also we can use for the basic inbuilt printf which ESP have. Then LED strip.h and SDK config.h. So the configuration means SDK configuration means you can find inside the CMake file. Uh, so it has all kind of settings inside that regarding that board, like pin configuration and interrupts. So which pin will act as that. So kind of things we can do the basic settings inside that. So it has all configuration kind of things. Then you just created a one uh, variable as a tag. Tag is an example. So just a kind of global variable you have created it. Then you created a one macro, which means that blink GPIO. So that config blink GPIO. So if you press control and yeah, first time you run it, to run that you can see here there is a options are there. So this is the ESP IDF version and this is the comport. So this is for ESP32. Then you should find out that ESP IDF build project. So if you press it, it will try to build here. It will take time to run the project first. So yeah, let's wait. Now as you can see that program is built correctly. So once the program build only, we can access the SDK config file. So you can see the new file, SDK config file came. So if you double click it, you can see all kind of data. So whether see that they will return all kind of memories and pins, so what pins will do, and interrupt, so everything they will return here. So this is the full configuration file for the ESP32. Here you are going to see that as defined blink GPIO config blink GPIO. Actually, this is the macro. Here, what they are doing is that config blink GPIO. They define that as a file. So if you click it, it will directly go to the SDK config file. So inside the config file, you can see it is set as a file. But some of the boards that GPIO of LED will be 5, but for my board it is 2. So you have to see that in the datasheet of the microcontroller. So now I am directly going to change that as a 2. Then I am going to create a static global variable, and I just return some if def macro. So for the LED blink and configuration setups. So two functions we have written. So what this means is that, so if the config blink LED RMT become true, then only you can access these functions, or else you can't access the function. So this is the end of that condition. So again we have two functions. So this is the macro function, so that we will define it at different time. So this is two function we have written: blink LED, configure LED. Then we have a app mine. So what we are doing is that first inside the void app mine, we are directly calling configure LED. So if you go to the configure LED, as you can see, ESP log guide. So this is why we need a ESP log.h in front of that. So rather than using the um, printf, we can use the ESP log guide. So the first tag, as you can see, before that we have written tag, so which we have declared that as a example. Here you can see that. So here you can change anything. Then what we are doing is that we are printing example configure to blink GPIO LED. So we are just configuring the GPIO as a LED. So what we are doing is the GPIO reset pin. First we have to reset the pin, whatever the state is that. So we have to reset the pin. The blink GPIO inside there, the pin number 2 will come. Then we are setting the direction, whether that pin is in input mode or output mode, whether we are going to give the input or take take the input or give the output, because microcontroller and processor don't know what this pin exactly going to do. So we have to assign whether is it a input pin or output pin. Then only we can process that pin and according to our need. So the first two things that we have to reset the pin, whatever it is. When we are going to access the pin, then we have to set the direction. So as you can see, this is the syntax. So this is the blink GPIO. So the second pin will going into GPIO mode output. So if you click it, so it will goes to the functions. So inbuilt function. So it will go to the GPIO .h. So there is a lot of inbuilt functions are there to use this kind of modes. So you don't need to worry about to write that thing. So this is the basic program. So now we configured our LED. Then we are writing while loop, which is the continuous loop. Then we are printing that. So percentages. So what is LED state. So before that we have declared that as a global variable 0. Then this is the conditional operator. So it is working as a like a um, if condition. So if this condition will check is LED state equal to true, whether is it a 1, then it will give a string of on. If it is not a true, if it is false, then this condition, this output will come. like writing if print on and else off. So this one conditional operator is equal to this one. So rather than writing the if condition, we can directly use this condition. So this is the use of that one. So it will directly print whether that LED state is on or off. So every time that will change. So that's why we are every time it is we are comparing it. Then blink LED. So now we are calling the blink LED. So inside blink LED, you are going to set the level, GPIO set level, whether you are going to set that as a high or low. So that's what you have to mention. So here we already have a SLD state as a 0, right? So it will that 0 value will be set to the second pin. So that's it. So we are only setting that specific GPIO. Again, if you come here, that SLD state will be not of SLD state. So first it will come as a 0, so not of 0 would be 1. Now that SLD LB became 1, then we are going to give the some basic period. So as you can see, config blink LED period. So normal blinking LED period, we are taking that variable from the uh, SDK config. So yeah, then the v task delay means it's kind of giving the delay. So every operation like this process done, then it will wait for 1000 millisecond. Again this while loop will run. Again the blink LED will come, then it coming becoming 1, then again it will come here, then that 1 became 0, then it's kind of 1010 it will change. So yeah, we are directly going to run that. So first we build it, then we are going to flash it. So we are flashing it. So there you have to select which mode you have to flash. So here it will use JTAG or UART or DFU. So ESP to BTEC cable will ask call as a UART, then it will directly try to flash it. So the flash is done. So after the flash is done, you can directly go to the serial monitor. So after the flash complete, you can go to the serial monitor. We don't need a debug console. So as you can see, video that LED is going to on and off. So I'm going to show the uh, ESP32 video. So there you can see the LED is blinking. So in that so you can see LED is blinking with every 1000 milliseconds. So there is a one red LED, so that is for power, and that blue color LED will blink always. Every 1000 millisecond it will blink. So this is the basic LED program which we are going. I'm going to use the inbuilt GPIO and normal header files in that function.